Today we're looking at solving nth root equations. So a couple of things we need to make sure we have written down in our notes is that when we are looking at our roots, so if we have the nth root of x, that number squished inside there is called your index, which we've talked about before. I just want to make sure you have it written down. And this number underneath your square root is called the radicand. Radicand, sorry, I got to write it on 2 lines. Okay, so the index is the one squished in there, the radicand is the number underneath. So when we're solving nth root equations, so we're going to be taking a 5th root or a 6th root or a 4th root or a square root, something like that. We have 3 different situations that come up. The first case that we have is when we have an odd index. So that's when we're taking the cube root or the 5th root or the 7th root. That index, the number that's inside the squishy part, is an odd number. When we do that, we're going to have one real root. Okay, and that real root is either going to be positive or negative. So it could be a positive root or a negative root. It could be 3 or it could be negative 5. It doesn't matter. It'll be positive or negative. So an example of that would be the 5th root of negative 32. The 5th root of negative 32 is negative 2 times negative 2 times negative 2 times negative 2 times negative 2 is what multiplies by itself 5 times to get negative 32. So the 5th root of negative 32 would be negative 2. Another example of this would be the cube root of 64. So if we look at the cube root of 64, we have 4 times 4 times 4 equals 64. So the cube root of 64 is 4. So you notice here, each time we only have one answer. Sometimes the answer is negative, sometimes the answer is positive. The second case that we'll have is if we have an even index, but my radicand is positive. So this would be if we're taking a square root or a 4th root of a positive number. So the square root of 16 or the 4th root of 276, something of that situation. Then in this situation, we're going to have 2 real roots. Okay, and that's because we're going to have a plus or minus in our answer. So just like when we did solving by square roots before, if you keep in mind a square root has an index of 2, so we always had a plus or minus with our answer. Same thing happens if we take a 4th root, we're going to have a plus or minus in our answer. Anytime you take an even root, you're going to have a plus or minus in your answer. So if we look at the 4th root of 16, well, 2 times 2 times 2 times 2 is 16. So the 4th root of 16 is really plus or minus 2. And again, anytime you're solving, the solving is when you're going to be using the plus or minus for those even indexes. The third example is still an even index, but now your radicand is negative. So in that situation, you're trying to take the square root of a negative number or the 4th root of a negative number. In those situations, if you're trying to take a 4th root of a negative number, there's no 4 numbers that multiply, 4 of the same numbers that multiply together to be a negative. Because if you multiply 4 positives, you get a positive number. If you multiply 4 negatives, you end up with a positive number again, because a negative times a negative is a positive. Times that third negative would be back to negative, times the 4th would be back to positive. So in these situations, we're going to have no real roots. Also keep in mind, when we took the square root of a negative number, we got an imaginary or complex solution. There were no real solutions. So same thing applies here, no real roots. So for instance, the 4th root of negative 81 would have no real solution. The 4th root of positive 81 is 3, but there is nothing times itself times itself times itself that is negative 81. So this would be no real solutions. So as we do this, we're going to get into actually solving these equations. So as we solve our equations, there are a few steps we're going to follow. So to solve equations, the first thing you're going to do is isolate the variable. Then you're going to take the nth root of both sides. Then you're going to check your index to decide if you need that plus or minus. So again, let's remind ourselves here, even gets the plus or minus. And then fourth, you want to check your answer and make sure it works. Oops, just kidding. Fourth, you want to solve. That was just a joke. Fourth, you want to solve. Fifth, you can check your answer and make sure it works if you want to write that as your answer. So if we look at some examples. Example number 1, if we have 4x to the 5th plus 10 equals 138. First thing we need to do is to isolate our variable. So we're trying to get x by itself, x to the 5th by itself. So we subtract 10. So we get 4x to the 5th equals 128. Now we're going to divide by 4. So x to the 5th equals 32. To get x by itself, now we're going to take the 5th root of both sides. Since we have x to the 5th, we want to take the 5th root. The 5th root of x to the 5th is just x. Here we're looking at our index. Our index is odd, so we're just going to go with our answer. We don't need a plus or minus. So what times itself 5 times is 32? That would be 2. So the 5th root of 32 is 2. So my answer to this problem is 2. And you could plug it in and see if it works, which it does. Second example I'm going to walk you through is, let me change colors. We've got x minus 3 to the 4th equals negative 81. Right now we have x minus 3 to the 4th power. I can't move that 3 because it's locked in with the 4th power. So we're going to take the 4th root of both sides. That would give me x minus 3 equals, here I'm looking and I have an even index, but now I have a negative radicand. And we know from the table we just made that if my index is even and my inside, my radicand, is negative, there is nothing times itself 4 times that could give me negative 81. So since there is no solution here, we're just going to write no real solution. You need to write no real solution. There is an imaginary solution. There's just no real solution. So you need to make sure you include the word real in there because we can't take the 4th root of negative 81. The third example I want to walk you through is if we have 2 times x minus 3 to the 4th equals 162. So first thing we need to do is get this x minus 3 to the 4th by itself. So we're going to divide by 2. That'll leave us with x minus 3 to the 4th equals 81. Now we need to get rid of that exponent of 4. So we're going to take the 4th root of both sides. Because my exponent is 4, we're going to take the 4th root of both sides. So it leaves me with x minus 3 equals, we have an even, so we're going to need a plus or minus. My inside is positive, so we're okay to take my 4th root. So 3 to the 4th power is 81, so the 4th root of 81 would be 3, but we cannot forget to put that plus or minus. Because we see this power is even, as soon as you see that even power, I'd put a plus or minus out there so you know you're going to have a plus or minus. To get x by itself, we're going to add 3. So we've got 3 plus or minus 3. And as always, because we have 2 integers, we need to simplify our answer. 3 plus 3 is 6. 3 minus 3 is 0. So my answer would be x equals 0 and x equals 6. So to go over this one more time, you need to get the variable by itself. So whether your variable is just on its own like it is here, x to the 5th, or if it's inside the parentheses to some power, get that by itself. Take the nth root. So whatever that exponent is, that's the root you're going to be taking. If it's x to the 5th, you'll take the 5th root. If it's something x to the 4th, you're going to take the 4th root. If it was x to the 12th, you take the 12th root. So you're going to do that to both sides. you need to think about what your answers are going to look like. If you're taking an odd index, you're just going to get one answer. If you have an even index, you're going to have a plus or minus unless the inside is negative, that radicand is negative. If the radicand is negative, no real solutions, because you can't take an even root of a negative number and get a real solution. If your index or your exponent is even, so if you have an even number, 2, 4, 6, 8, then you're going to have plus or minus in your answer, assuming that the number inside your square root is positive. That's going to give you those two solutions.